Hey guys, welcome back to another video. In today's video, I'm going to be doing some practice problems regarding extrema and calculus, so let's begin. Okay, so this problem is asking us to determine whether each point that is labeled is either relative maximum, relative minimum, absolute maximum, absolute minimum, or neither. So let's look at point A. Point A, in comparison to everything else, is a absolute maximum of the graph. So now let's look at point B. Point B is not defined on the graph, so we can say that it's neither. Point C is defined on the graph, and it's the lowest value of the entire function, so we can say that's the absolute minimum. Point D is at the same height as A, which means that it's also an absolute maximum. Point E is not an absolute minimum, but it can be a relative minimum because it's the lowest point in comparison to its surrounding points. So we can say that E is a relative minimum. F is similar to E, but instead it's a relative maximum because it's not as big as A and D, but it is bigger than its surrounding points. And for G, G is not defined, so G is neither, or none of the above. Okay, so now it's asking us to find the critical numbers of the following function. So let's differentiate it. So a critical number occurs when f prime of x is equal to 0 or when it's undefined. So let's say f prime of c is equal to 0 is equal to 2c minus 4 because we just plugged in c into x. So we can add 4 to both sides. We have 2c is equal to 4. Divide both sides by 2, you get that c is equal to 2. And we get that our critical number occurs at x equals 2. So for this one, we can factor out or like cancel out some terms. So you can say that f of x is equal to 2 over 6, 1 over 3 x cubed minus 15 over 6, 15 over 6. They share 3 in common, so we can get 5 over 2. So we get 5 over 2 x squared. 36 over 6 is just 6x. 30 over 6 is just 5. So now we're going to differentiate to find the critical numbers. So we have the derivative is equal to x squared minus 5x plus 6. But now we have to find when f prime of c is equal to 0. So we can say that 0 is equal to c squared minus 5c plus 6. What we can do here is factor out. So these two multiply to 6. What factors of 6 to add up to negative 5? Negative 2, negative 3. So you can say that c minus 2 multiplied by c minus 3 is equal to 0. Or that the critical numbers occur at x equals 2 and at x equals 3. Because this is what makes the derivative 0. Okay, so now we have this absolute value function. Absolute value functions always have an undefined derivative when it's equal to 0 because there's two contradicting slopes at that point. So this can be easily said that the critical number of the following function is at x equals 2. Okay, so now we have the function sine of x from the interval 0 to 2 pi. So let's differentiate that. F prime of x is equal to cosine x. And we need to find out when cosine of c is equal to 0 or when cosine something is equal to 0. So from the unit circle, we know that cosine is equal to 0 at pi over 2 and at 3 pi over 2. So we can say that c is equal to 3 pi over 2 and pi over 2. I meant to write this over here, but same thing. So we can say that the critical numbers of the function from the interval 0 to 2 pi, because this starts from 0, you go all the way around 2 pi, are x is equal to pi over 2 and x is equal to 3 pi over 2. This can be seen in the graph of sine of x, which goes like this. This is 2 pi, over here is pi over 2, because that's when it reaches its largest value. This is 3 pi over 2 when it reaches its lowest value of negative 1, and positive 1 is up here. Okay, so now we have this problem says that f of x is equal to x squared multiplied by 4 minus x, which is the same thing as x squared multiplied by 4 minus x to the power of 1/2. We're going to differentiate using product rule. So I'm going to keep the first term the same, differentiate the second term using power rule, and then we multiply by -1 because of chain rule. And then we add on the second term, which is 4 minus x to the power of 1/2, multiplied by the derivative of x squared, which is just 2x. So now we have f prime of x is equal to x squared over 2, 4 minus x to the power of 1/2, minus, sorry, it should be negative. And then we add positive 2x, 4 minus x to the power of 1/2. So I'm going to make some more room. So I'm going to erase this and write, as you can see here, they share common terms right here. So if you were to combine these two, you can say that f prime of x is equal to negative x squared multiplied by 4x, because there's a 2 right here. And when we put this into one term, we're also going to multiply by the denominator so that it stays the same. So we multiply 2x by 2 and square root of 4 minus x by square root 4 minus x, which turns it into just itself, which is 4 minus x, all over 2 square root 4 minus x. We can simplify this even more and say this is negative x squared minus 4x squared plus 16x over 2 square root of 4 minus x. F prime of x simplifies to negative 5x squared plus 16x all over 2 square root of 4 minus x. I'm going to make some more room. Okay, so we're going to find the critical numbers. So to find when f prime of x is equal to 0, we're going to deal with the numerator. But when we look for when it's undefined, we're going to look at the denominator. So let's look at when it's equal to 0. F prime of c is equal to 0. We can multiply this bottom part into 0 and still be 0. So it'll be negative 5x squared, sorry, 5c squared plus 16c. We can factor out a c. I get negative 5x plus 16. This is c again. And we have that one extrema is equal to 0. And that the other one, if we cancel out the c, we divide by c. And 0 divided by c is still 0. We have negative 5c plus 16. 5c is equal to 16. C is equal to 16 over 5. And we get that our second critical number is that x equals 16 over 5. But now we're going to look at when f prime of x is undefined. We're looking for when the denominator becomes 0. So let's just say 2 square root 4 minus x is equal to 0. We have 2, we can divide by 2, we can raise everything to a square. Now we have 4 minus x equal to 0, and now we have x is equal to 4. So we have our last critical number at x equals 4. Okay, so this problem is asking us to find the absolute extrema on this interval from 0 to 5. So the first thing I'm going to do is plug in the endpoints. So let's see, 0 minus 0 plus 5 is just 5. This one is 25 minus 30 plus 5, which is 0. So we're going to find the derivative of the function to find the critical numbers. So we have 2x minus 6 as a derivative. Okay, we take down degree, which is just power rule. Take down degree, subtract 1, get to the power 1. So we're looking for when f prime of c is equal to 0, 2c minus 6. We get that c is equal to 2c, and that c is equal to 3. So now let's plug in f of 3. F of 3 is 9 minus 18 plus 5. This is negative 9 plus 5, which is negative 4. So we get that the absolute maximum on that interval occurs at 0, 5, and that the absolute minimum on the interval occurs at 3, negative 4. we're going to do the same thing for this function. So let's find f of negative 2. F of negative 2 will be negative 8 plus 6 plus 1, which would be negative 1. F of 2 will be 8 minus 6 plus 1, which would be 3. So now we're going to find the critical numbers. F prime of x is equal to 3x squared minus 3. We're going to look for when f prime of x is equal to 0. So f prime of c is equal to 0, which is equal to 3c squared minus 3. Now you have 3 is equal to 3c squared. So these cancel out. We have 1 is equal to c squared, or that c is equal to positive or negative 1. Let's plug in negative 1 first. So now we have negative 1. Negative 1 to the power of negative 3 is negative 1. Plus 3, which would be 2. Plus 1 will be 3, which is the same value as over here. So now let's find f of 1, which is 1 minus 3 plus 1, which would be negative 1. So this means that the absolute minimums of this function on this interval occur at the points negative 2, negative 1, and 1, negative 1, and that the absolute maximums on this interval occur at 2, 3, and then negative 1, 3. That'll be our final answer. Okay, so now we're going to find the absolute extrema of f of x of the greatest integer function from negative 3 to 1. So what we're going to do is plug in the endpoints, negative 3. So as you can see in the graph, negative 3, which is equal to negative 3, and f of 1 will also equal to 1. So as we can see here, there's some interval where that this is the minimum. So you can see that the absolute minimum of f of x occurs from the points negative 3 less than or equal to x less than negative 2 at the y value negative 3. While the absolute maximum occurs only at one point, which is the endpoint of the interval, at 1. So you can just say this is just 1, 1. So the absolute minimum has an interval where it can exist, while the absolute maximum has one set point where it exists. Okay, so now we're going to find the extrema for sine of x from 0 to 2 pi. So let's plug in 0, sine of 0 is 0, sine of 2 pi is also 0. So now we're going to find the derivative. This is really similar to the other one we did, but this time it's a closed interval. So now we have cosine x. We have to find when cosine of c is equal to 0. So cosine of x is equal to 0 at pi over 2 and at 3 pi over 2. So this means that c occurs at pi over 2 and at 3 pi over 2. So now let's plug in the values pi over 2 first. So sine pi over 2 is 1, while sine 3 pi over 2 is equal to negative 1. So the absolute maximum on this interval corresponds to the point pi over 2, 1, while the absolute minimum on this interval corresponds to the point 3 pi over 2, negative 1. And so if we were to draw the sine function, it would look like this. So this is 2 pi over here, 0. This is pi over 2, and then you have 3 pi over 2. As you can see here, this is the absolute maximum and absolute minimum over here. Okay, so for our last question, we have to explain why the extreme value theorem fails for 1 over x on the interval negative 1 to 1. So we have this hint that says, recall that extreme value theorem guarantees the existence of extrema, but in what situation would this not be guaranteed? When does EVT fail? Extreme value theorem only works when the function is continuous for all values on the interval. Okay, so f of x is equal to 1 over x is undefined when x equals 0. Which means that this function on the interval -1 to 1 is not continuous for all points of the interval. If a function is not continuous for all points on an interval, that means that the extreme value theorem does not guarantee that a maximum or minimum may exist. So that's why the extreme value theorem fails. So extreme value theorem fails because f of x is discontinuous at x equals 0. Excuse my handwriting. Thank you for watching today's video. I hope you enjoyed, and stay tuned for more.